Let's work a few problems calculating probability using the normal distribution as a probability distribution. This is starting with number 11 on the test review. Here it is right here. Assume the random variable x is normally distributed, which that's always going to be the assumption on this module because we're using the normal distribution. But it gives us a mean, mu of 50, and standard deviation of 12. Compute the probability that x is less than 65. So this is really just kind of an intermediate word type problem for what we were doing in the previous section. It says x less than, so that tells us it's going to be area to the left of the z-score we find. So the distribution, just to give us a visual here, you don't have to have this, but you know the mean of this thing is 50 according to the problem, and we want x less than 65, so 65 is over here somewhere, and the area to the left of it is that. So we can see already that our answer when we're done should be greater than 0.5 because this is more than half the curve here. And we find that in order to define this, we don't have a table for every scenario. So we don't have a table for distributions with a mean of 50 and a standard deviation of 12. So we standardize this sucker so we can use our table. And that's where those z-scores come in. And when you standardize it, this middle becomes 0, and then you start having 1s, 2s, and 3s out either direction and negative ones on this side as you count the number of standard deviations you go. So the z-score always for the mean of a distribution, if you turn that to a standard z-score, you would get 0. So, but anyway, remember that z is x minus mu divided by sigma. So in our problem, the x is 65, the mean is 50, and standard deviation was 12. So we get 15 over 12. That's 1.25. So the z-score that corresponds with this 65 is 1.25. And that just enables us to look it up in a chart. So that's saying that the 65 is 1.25 standard deviations above the mean. 1.25, 1.205 here. 8944, no, is that right? Yeah, 0.8944. So this area here is 0.8944. And that is the probability. Looking at this as probability, that's the probability that a score is less than 65. So they're saying with if you were choosing one person from random in this distribution, the probability of getting somebody that had less than 65 on whatever measure this is would be 89.44% or 0.8944. The next problem, there's a few different types, but these are like that first video that I did where, this was 11. The first video I did, there's only so many really different ones. There's less than, there's greater than, or there's to the left of, to the right of, between, and outside of. This less than, that's to the left, that makes sense. This next one is greater than, so that's going to be asking for area to the right. Let's see, this one, mean of 100, standard deviation of 10. What's the probability that x is greater than 108? So just to have a visual, here's the 108, and greater than is to the right of it. So now we're looking for area to the right. So we're going to find the z-score for this 108, and that is 108 minus 100 divided by standard deviation of 10. And that's 8 over 10.8. And we look that up on positive again, so 0.80. So 0.8 is right here, 0 is right here, 7881. Now remember, the chart always gives us the area to the left, so that's 0.7881. And from those that last video, we learned if we were looking for area to the right, we always take 1 minus what the chart tells us, and that gives us this area over here. Subtracting this area from 1 gives us the remaining area there. So what is that, 0.2119? Is that right? Yeah, that looks right. So that's the area here. So the probability that selecting somebody at random, the probability that their score is higher than a 108 is 0.2199 or 21.919%. The last one of this group, 13, it looks like a between. It looks like this. That's a between problem. What's the probability that x is between 37 and 85? So we're going to have to find a z-score for the 37, a z-score for the 85, and then we know how to find the area in between. We look them both up in the chart, both the z-scores, and then we subtract the smaller from the larger. But let me give us a little visual reference here. What is the mean? The mean is 70 according to the problem. So 37 is over here somewhere. 85 is over here somewhere. And they want x between those. So that's going to look like that. When we do the z-score for 37, it should be negative because that's below the mean. And then we'll have a positive one over here. So this first z for 37, I'm just going to write that so I remember which one's which, is 37 minus 70 divided by standard deviation, where is that, 12? Divided by 12. That is, what is that, negative 33 over 12? Is that right? And let's see, what is that? I got to do good old-fashioned long division here. 24, 9.75. So that's negative 2.75. And then the z-score for the 85 on the other side is 85 minus 70 divided by 12, which is 15 divided by 12, and that is 1.25. So let's look both of these up. Negative 2.75. Negative 2.7 right there. 0.5 right there. 0.0030. This one's 0.0030. And 1.25. That's my other chart. 1.25. 89.44. And we're going to subtract the smaller from the larger, right here. And we get 0.8914. And that looks to be right. So that's those type of problems. Next video we'll do the next grouping, or at least a couple of them.